Today, we are going to discuss some architecture things regarding your code, because many developers, just creating their game, focusing on gameplay, which is pretty important, but very often they forgot about the code architecture, the code quality, and stuff all around. So today we will discuss how you can create a better architecture, or if you are already in development of the game, or you have some existing code base, how you can refactor or do something with your current state and make it more viable for the future. Very often I can see some kind of development like this, huge function with everything inside, and it just works. But that's not the best way how we can proceed. As you can see, the architecture is pretty important, not only in the real life, but in the development as well. And you need to decide what is important for you, and to see what's wrong in your current state. This is very hard to do because many people are kind of blind when they are developing their game, because they like their game, and it's pretty hard to spot on what's wrong with their code base and what's wrong with the code itself. Also, which is pretty important and extremely hard to do, it's to maintain the quality during the whole development, because you can set up on the first day, great coding styles, great architecture, and great stuff all around. But when your product is moving further and further, and milestones are coming up, you will, just the code will get broken, and the things will be broken in the future. So, and also you need to decide if you really have to care. Many people don't care about their code quality or the architecture of their products, and it's absolutely fine if you can do that. If you have small game, for example, if you are targeting one platform and everything's absolutely fine, and you don't plan to port the game for the other platforms or create another game with the same code, it's kind of fine to stay with this current state if you are happy with it. So right now we have two approaches. You have an existing code base, or you are starting with the new one. The existing code base is very tricky to do something with it. First of all, you need to analyze the current state. You need to see what's wrong. You need to sit with your team, talk about it, and discuss things which are not okay in your source code, and what do you like to change in the future. You need to set up some goals. What is the benefit of recreating the architecture, or creating another module, another system. You need to set up the goal. What's the purpose of this, and why are you creating or doing this? Also, the benefits are pretty important. If you are working in small, just developers teams, it's pretty easy to convince them to do this. But when you are working in a company, you have some management, and you need to also convince them to listen to you, and to give you the time/money to do your work, to make your architecture better and refactor things. And also, don't think about just making everything at once. It's pretty impossible. But I see in those kind of situations where team just decided to go all in and refactor everything at once, and most of the time it can end up pretty bad. Maybe it's worse state than before. So make iterative changes, and don't try to solve everything at once. It's easier if it's your current architecture or your current source code is in modules, but it's also something which is pretty rare in many projects. So in some high-level view, this can be your game. Just some core or game or something like that, audio, Steam, enemies manager, AI, other stuff, just everything, split, connected together, and it just works. It's fine. But when you're adding more developers to this team, to this game, you start feeling issues. If you are using some version control system, it can be a little bit easier if you are using feature branching, all this stuff all around, but still, this kind of architecture is pretty hard to maintain and even to extend it for the further purposes. So what do you need to do if you like to improve this kind of state of your architecture? But first, do you think you have your architecture in this current state, and do you plan to upgrade it in the future? If so, please raise your hand. Okay, few people here. Great. That's absolutely fine. Everybody been there. I think not only once. Many people tried to improve their code in next projects, next games, next application, but it's pretty hard to do on the first time. So if you have this kind of architecture, focus on one piece at a time. And even though you feel, for example, your gameplay logic can be split into 20 modules or something like that, and it's your best scenario, don't do that on the first time. Please try to focus on a big chunk, which is maybe not the best way. You don't feel it as a developer, hey, this is the best way. No, it's not generally. But start with the big chunks and split it in the future. Break it down in the future iterations, and don't try to do everything everything at once, and do these things in the big chunks, because this will save you many time. Also, the management will be much happier because they will see the benefits much quicker than just making everything at once. Also, which is very important, is thinking about public API and some private stuff. Because when you are splitting the logic, when you are creating a new architecture for your game, or if you are just thinking how everything will be stitched together, it's important to think about what the module will provide for other modules. Like if you are creating an enemies manager or enemy systems, what API is going to have this enemy system? Is there going to be some spawn enemy method or something like that? So think about it. Think about public interface. It's extremely important because this is the way how other modules will communicate with your module. And also you can make this public API very simple, which is very great goal to do, because the simple API is great. You can hide the complexity, and you can also hide any future upgrades if it's viable for you. So do this. And again, I think the biggest message from this slide is take one piece at a time, and even bigger one. I have seen teams where they try to make these things into small modules, and even to 20 modules at first try, and it ended up very badly. So take one piece at a time, and even the bigger one. The better way, or easier way maybe, is the new code base. You need to decide or define main and crucial parts of your game. What defines your game? What defines your gameplay? What defines your, I don't know, if you are, for example, creating a new big game with open world, so open world logic is pretty important for you. Think about what's defining your game, what's defining the crucial parts of the game, because these systems should have extra care than the other one. First things is to split those systems into modules. It's just a basic tip. Modules are available in, I don't know, in every language right now. But if they don't, you can just emulate them. Not in the compiler or something like that, just in your code base. Just think about it, hey, this is just one module, this is another module, and we can't see into each other modules. It's absolutely fine to do this, and maybe easier than trying to utilize some other techniques like, modules in engines where they are not supported by default. It's kind of harder to do, but it's still possible. But you can start like this. Very important things is to create lightweight dependencies between systems. It's crucial because very often you will try to improve your system or maybe replace with another one. And if you have hard references to your system, it's pretty hard to do. And if you have public API, which is very, very brief, with very small amount of methods, and they are very powerful in the end, that's absolutely fine. But the hard references between modules, it's something what you don't like to do because it's tricky in the future to replace those things with the newer one or iterate over them. And very important thing is your team needs to be on the same page with you on this. again, I've seen teams where someone was, very happy with his very happy with his proposal about architecture, and other team members, they didn't even care, and that's a bad thing, because your whole team is going to work on same thing, and if they don't respect, or maybe it's the better word, is to understand the architecture, what you have planned for this product, for the game, it's bad, and it will end up badly. So sit with your team, talk about the architecture, and grab the feedback, or maybe just work whole architecture with your team. But it's good idea to have someone who will be the holder of the architecture, who will decide those modules, who will decide the architecture. But he will listen to your team, and he will be on hand and feel the needs of the team, and that's very important. So if you are going to do this way, you may end up with something like this, which can be pretty good. It's very simplified diagram of something, of some game or something like that. So don't take this extremely seriously regarding the references, these arrows and these stuff around. But the idea behind is separate the logic and hide the complexity behind public API. So for example, as you can see, there is a platform integration module. There is some interface behind it, and there are implementation for Xbox One, PS4, Steam, and maybe other services which would you like to use in your game. And this is great to do, because other modules don't care if they are posting to, I don't know, Xbox Live or something like that. They're just posting to platform integration API. They're sending some data like, I don't know, updates or some leaderboards or something like that. And they should not care generally if it ends up in Xbox One or PS4 or Steam or GOG or something like that. And that's the great thing to do. Enemies manager also, your code should not care about extreme specifics of the logic behind the enemies. You just create archetypes of those enemies and drop them to the scenes, and they just works. And that's great, because if you have some direct reference to enemy, it's kind of hard to decouple it afterwards, because it will rot in your scene and stay there until forever. Also, some foundation frameworks or modules are very common when you are hiding some logic which is utilized across the system. Beware, this is not a static class or utility class with ton of methods. This is still another module with classic classes, maybe generics one, because object pooling is a great idea to do as a generic. There are some math helpers or generic structs to handle or transfer your data between the systems. So this can be kind of ideal state of your architecture. And it's hard to start with this, but you need to iterate and move forward to this architecture. And again, as I said on the previous slide, the whole team needs to understand what's the goal, what's the purpose, and again, what's the benefit. Because if you force them to do this without, trying to get them the understanding what's behind, it's okay-ish sometimes, but it's again not the best way. The team needs to know the benefits of the architecture, why they are doing this, because sometimes making this kind of architecture is generally more code. It's more work, it's more classes, it's more files, and as we know, many developers don't like to do this. They just need to like to focus on the logic, on the game itself, and they like to just program and don't waste their time with creating interfaces or something like that. They just like to program and write the code. So you need to discuss this with them and try to make them happy with this architecture. And again, they need to understand those benefits of this architecture. Very important part when you are creating a new, or maybe you are trying to refactor existing architecture, is a decoupling. You need to think about responsibilities of specific classes or even specific methods. Very often I can see, God classes where there's a ton of code. Also the methods which, if you just call it, it will do ton of things behind the scene, which is kind of not the best way how you can do this. You can split the logic across small private methods and create a public API, which is some public method, which will call these private methods underneath. That's absolutely fine, but still you need to decide by yourself if this public method is not doing a ton of work, if it's okay to do this kind of amount of work. And I already mentioned them is the God classes. It's very obvious pattern in many source code bases. One God mono behavior in Unity very often is kind of game director, or I don't know, something like that, global manager of everything inside the game. And UE4 has its own God classes, or classes they are live for a long time, and many people will abuse them for using them as a God classes and stretch every method or stitch every method inside them, but they don't need to be inside them. They should be decoupled from these God classes. So great thing is just don't create God classes. Try to make them small, effective, and the reason why is they are really easy to extend in the future, and also they are pretty easy to replace, which I think is maybe more important, because very often you just came with a new idea, a new way how to solve your problem, or new gameplay logic, and it's easier just to take out some kind of class, I don't know, enemy following, and try to replace it with something enemy flying or something like that. And if it's hidden behind some public API, this will never touch the rest of the code, because they don't care. They don't have references for this kind of classes. Yeah, your scenes or maybe some gameplay scripts they have. That's something which is hard to get rid of it, but that's kind of fine. But still, the rest of the source code will not care of this replacement. And it's going to be much easier for you to do this replacement because there are no references anywhere. You don't have some God class which is references with via some static instance of, I don't know, singleton-like thing. And it's fine. Make use of weak pointers or references where it's suitable. I very often see just hard references, and not many developers understand, or they don't even know about weak pointers or weak references. And that's a great thing to do, because when you are holding a hard reference, the garbage collector or some kind of memory manager behind your game, if you are using Unity, there is a garbage collector. If you are using Unreal and using the Unreal objects, there is a garbage collector. And if you have hard references to them, it's very hard for the garbage collector to collect these classes and get rid of them if they are not usable, or they are not active in your scenes. So think about this. If you can just have a weak reference. Weak reference have its own disadvantages. You need to check if the weak reference is valid, because sometimes they can just disappear because the garbage collector will decide to get rid of them. But I think it's small price in some cases compared to the memory overhead, which is sometimes caused with huge reference graphs and holding ton of objects inside the memory. So think about it. I think nearly every language or nearly every engine can support these weak references, and it's powerful tool, but it has its own disadvantages. So, for example, if you are holding a data which can be destroyed afterwards, weak reference is a great idea, because the data, if you have some huge table with, I don't know, some statistics about player, or some I don't know, stats for the enemies, and if you are holding them with a hard reference in your God class, you will never get rid of it, because there are still references somewhere. So think about it. Weak references is a great way how to solve memory management, or not solve, but improve your memory management. This is just a small example how game manager or something like that can looks like. The method just do everything. It's starting the game, it's spawning enemy, it's getting current score, it's sending some kind of network request. From your feeling, this is bad, but everyone's been there. Everyone saw this class. Everyone added his own method to this class. Maybe you are ashamed of it. I was that time when I does it, but it's something which is inevitable in the project where these God classes are already existing and they are living, and you don't have a time, for example, to iterate over over the architecture that time. And then very often also the game manager is a God class, so it has some kind of singleton implementation behind and is available from everywhere. And if you just, I don't know, delete it from disk, whole game will broke up because there is in every single file there is a reference to this class and doing something with it. So this can be, for example, a great test for your code base. Just strip away this God class and see what the compiler will tell you. How deeply is this God class or this kind of singleton class is integrated in your project. If you see 2 or 3 errors, it's kind of fine and easier to solve. But if you see hundreds and hundreds null references or something like that, it's something you need to think about if it's, for example, worth it to work on this right now or maybe in the future. What's the motivation behind the decoupling? Again, it's easier to debug because, for example, if you have small parts of the logic, you can take it, isolate it in the separate scene, and test it out. Because very often, the classes in even the greatest architectures can affect each other. So, if you have small pieces, small modules, small classes, you can just take one of these, separate it from the other, and test it out if it's working fine, debug, and this stuff all around. Again, it's easier to maintain and upgrade those things because, again, there are small things, and small things are easier to replace, and they are not referenced in the all parts of your source code. For example, a very common thing is renderer module, because right now there is a ton of rendering APIs. There is, I don't know, new consoles, for example, will came out somewhere, and we need to be ready for replacing this renderer with another one, or for example, if you're developing multi-platform game and you need to support 5 or 6 rendering APIs, and it's kind of hard to do if you have one God class which is called renderer and is doing everything, because first things you need to put some if-defs or something like that, and the class is going to have 1,000 lines, and that's something what you probably feel it's not the best way. So small chunks, small classes, small modules are easier to replace, maintain, and even upgrade. And I think the biggest benefit is the debug. Very often you can find the issue in your source code easier and quicker if you are just isolating the logic, which is maybe the problematic one, into separated scene and seeing the issues. And also if you are using third-party some APIs and you find out there is some issues, they will like to have some reproduction project or something like that. And if you say, okay, so here is my 2 terabytes game with source code, and see the issue there, they will not be probably happy. So they will like to have some small, very small project where the issue is visible. And this can help you. This can help you solve this issue. And it's inevitable. Those developers of those SDKs are also people, and issues will be there, and they will need to have the good reproduction steps and even small repro project to see the issue. The common problem is performance versus complexity, and especially in the games. Because creating a robust architecture will lead to complex system, and this complex system can be very hard impact, can have a very hard impact for your performance of the game. And it's kind of fine if you can afford it. If your game is using 10% of the CPU, so you can spend another 10% for your great architecture. It's absolutely fine if you can do it. If your market which you are targeting is ready for this. But sometimes it's very tricky to make a complex architecture, which is great, modules, everything which I said before. This sounds like a dreamland, but it's very hard to create it at the first time. And again, it's very hard to make it quick and fast on devices. So you need to think about how you can optimize your complex systems, because you don't want to get rid of them. You spend 2 years of creating great architecture which works, and your team is happy with it, and then you will see on your target device it doesn't perform well, so you just scrape it out and replace everything with one God class singleton, and it works fine. So that's not the best way. You need to assume, you need to create some assumptions how your game will behave, and not try to create an ultimate framework for everything for your game. Just think about your game, what's the main goals of your game, what's the crucial parts of your game, and bend this logic, bend the framework, or bend the architecture behind it or around it. Not try to create an ultimate framework. Again, this is a common issue and very easy to fall inside this rabbit hole, because as developer, if you are just get a task, create great architecture for your game, for our game. It's great. I like to do that, and you will over-engineer it. You will create it as your baby, and you will create it for every single instance of your game. You can create it with flying enemies, but your game is about racing. So why do we have a flying enemies inside of the code? It's something that you need to think about, and not create redundant code which is not usable for your game, because this will add the overhead, and the complexity will increase with this. So it's tricky, but it's doable. Very important part when you are creating new architecture for your game inside Unity or Unreal 4 is it's not every class or every logic, every system needs to be an active entity, because these engines have some kind of mechanism putting those classes on the scenes, and they behave somehow. So, for example, mono behavior in Unity, or actor or pawn or something like that in Unreal, it's easy to make a logic behind them, or on them, because the Unity and the Unreal will give you a ton of events, and very easy to get references from the scene, and it's easy. It's just easy and straightforward way how to do so. But having ton of mono behaviors on the scene, also actors or pawns in Unreal, will cost you a significant amount of the performance. Just don't think about the way you will create everything around these objects. It's very common pitfall, and many people do it, and afterwards they will just see the performance is extremely slow, because you have, thousands of mono behaviors for your every single class in your framework or in your architecture, and Unity will need to do its things around it. It needs to send a message for update or fixed update or something like that. Even though if you are not listening to this method, it needs to do some magic behind it. So it's very common tip. Create just few of these. Reference your framework and your system underneath, and just if you need listen to update, maybe you can create one class which is called updater in Unity, and reference other objects and just for each them and trigger the update on it. It sounds crazy, and I get it, but very often it's much more quicker and faster than just having a ton of mono behaviors on the scene and waiting to Unity to call the update method on these classes. It's just something you need to decide, in the first step when you are creating the architecture, because when you have these mono behaviors on the scenes already, it's extremely hard to get rid of them afterwards. So, if you are creating this system, don't try to utilize these active entities on the scenes. If it's not extremely necessary for the logic, I don't know, if you are just creating some spawner class, it generally needs to reference the class, the scene where those things are going to be spawned. So that's fine. But if you are creating, something, it's just object pooling generic class, why it should be mono behavior? It shouldn't be, and it's something which should not be listening to update and other events in the scene. And again, it's a very common pitfall, and many code bases doing this, and it's hard to get rid of it afterwards. As I already said, these entities or components have very significant impact on the performance. Just think about it. If you have Unreal, you can see the source code behind. If you have Unity, it's kind of hard to think what's going on behind the scene. But if you just do a simple measurements, you will see the calling of update methods by Unity and versus calling update methods by your hand or on your classes. It's much faster and significantly faster. But those engines are evolving. Also, Unity and Unreal just trying to create a modern systems how you can utilize the logic and how you can be more performant on your target platform. So, for example, it's hot news, or not maybe the hot new in the Unity is the ECS and the job system, which you can utilize. It's something like switching the logic behind. You have one entity on the scene which represents your enemy or something like that, and ECS just forcing you to have very small amount of these things and focusing more on the data, because the enemies on the scenes are fine, but the data behind are the something which defines those enemies, giving them abilities, giving them HP or something like the data behind, and those entities or instances on the scene just working with those data. So generally, you can just have a one or something like that logic shared between and the data which is going to be processed in parallel, for example. So if you just want to improve your performance, it's great to see how ECS or job system in Unity works. And also the task graph in UE4 is extremely powerful. The parallel programming is very important, and I will talk about it in the following slides. But task graph in UE4 can be significant help for your logic, how you can improve your processing, and how you can hide the complexity behind or split it into separated cores or something like that. And generally, if you are a low-level programmer, you maybe heard of it. It's the SIMD. It's very often pattern how you can work on multiple data with single instruction. And it's great because many modern hardware supports it, even the mobile phones, and it will speed up the game logic significantly. Also, very common pitfall: these active types or active entities, as I labeled them before, the mono behavior or actors or something like that, are very often used and abused for just data-only stuff. They just hold maybe one method with ton of properties with data. And why should they do live on the scene if it's not really necessary by your logic? And think about this and try to separate the logic and the data. This will help you significantly in terms of performance, because you can, for example, split the logic where you are reading the data from somewhere, and if the data are already tied to your entity, you can do that. So try to separate the logic and data. It's very common, again, to do this. For example, Unity offers you the script table object, and you have its data tables, and it's very same thing. And you can do huge magic with it, and gives you a huge performance benefits for your game. And just thinking about the game as a processing of the data, which is generally is it. You have few logic and working with the data. Your logic is behaving based on your data, based on how your enemies have hit points or something like that. It just behaves, and everything's it's around the data itself. You can, for example, share one data source like enemy config across the enemies. If you have entity called, I don't know, enemy, for example, and you have properties with HP and damage and this stuff around, these things are going to be copied for every single instance in your scene, and it's significant overhead for your game. So if you are creating some script table object which will hold up the config or the values for the enemy, for example, the HP is something which needs to be related to every single enemy, but for example, the damage and other attributes of the enemy can be shared and shouldn't be copied across the instances. And it's extremely easy to maintain, because if you have game designers in your team, they will love it, because they should not open the class and edit it inside. Or maybe in Unity you have some fancy editor for this, because you're modifying the properties, the public properties. But if they can have, for example, some kinds of Excel sheet where everything easy for them to spot on, everything easy to work on it, like some kind of data analysis. They can, for example, sum up the damage, and they just think about how a new enemy will behave. It's very often, I'm not saying for everybody, but it's very often easier for them to work on. And Unity or even Unreal supports importing some Excel sheets or CVS files or something like that, and you can use this data for your game like a data sources, and it will help you significantly. And again, your design team probably will love you afterwards. The last thing, which is very kind of low level, but it's something which you may think about it because it can be very helpful for you, is data packing. For example, if you have some ID of the enemy or something like that, and it can be just put everything inside in one byte, and everything can be added up to continuous array. It's very great for your memory because you are not wasting because, for example, if you know your enemy will have 1 and up to 10 or something like that ID, why do you need double or float for this or something like that? It's something you don't really need for this. So you can limit the memory usage for this and pack the data together. And this is extremely helpful when you are making a parallel logic. Again, I will talk about the parallel processing afterwards, but this is something which maybe it's a little bit low level, but can helps you to process your data, in the faster way. Something which I really like to talk about are these bad boys, the singletons. It's very often common pattern in the source code. It's something everyone have even one singleton in the scene. If you don't, you are lying. So the singleton is something what you feel it's something I need it, but get rid of them because they have ton of disadvantages, which you may not see on the first side, but in the future you will see them very, it will limit you when you are creating some new logic, when you are extending, or where you are, for example, porting your game to another platform. The singletons can be beneficial on the first side. It's something which it's easy because you create, they are available from any part of your source code, and it's something which is easy to fall into. But don't just get rid of them. They are really core of the issues, of many issues. So try to not to look at me as a guy who is hating the singletons. Try to listen to this and accept this challenge and removes every single singleton from your game. It's hard. I do get it, but it's beneficial. But why do they even exist if they are so evil? And many people talk about them as the evil thing of the programming. You can access anything from anywhere. This is very common reason why people will fall into the singleton trap and make their code as a singletons, because you can just call this method from anywhere, and it's very easy for you to do this. It's quick and easy solution. I think it's kind of dirty solution, but it works. But very significant disadvantages and also an advantage is that they live forever. Because there is singleton, there is hard reference for its instance in some kind of static property, and they just live forever. It's something which can be beneficial for you, but not beneficial for the memory management or something like that. For example, if you are holding a reference to, again, big chunk of data inside your singleton, they will never be unallocated from the memory. So think about this. And also singletons can be hotspot when you are creating a parallel logic, because they can create race conditions and other stuff if you are not careful enough. So I hope it's kind of visible. This is some kind of code which can be seen in many code bases. The player instance, you will get a player singleton and lower the HP with your magic global constants from somewhere. You just get the game HUD and show some kind of text, and again play some audio cue or something like that in this method. It's pretty straightforward and kinda it looks fine, but it's not something you really likes to have in your source code, because these instances are something which can really rot inside in your code, and it's very hard to get rid of them. And if you are creating an architecture or refactoring your current architecture to something better, which we have shown on the first slides, this is something which is going to be extremely hard to get rid of it, because this is something which is already rotten in your source code, and it's hard to get rid of them. But there is a hope. there is something which is called inversion of control, or maybe dependency injection. It depends how you call it, but I like the inversion of control. It's something, these classes or methods will get the data or the references from the caller. They will not grab them through some global magic instance or something. They will get it from the caller. They just don't care where the instance is get from. They will just get it as an argument and they will work for it. That's a great idea, because you don't care about if the singleton is active, is created, and this stuff will run. Also, you can split the logic into constructor injection and method injection. This is very good idea to think about it, because constructor injection will needs to have references for the class which are crucial for the even living or starting up the class. So something which is used for a whole lifetime of the class. I don't know, maybe it can be audio system if the class is working with audio very extensively. So you don't want to pass this audio system with every single method. So pass it as a constructor injection or constructor argument and put it inside your property. And if it's something which is usable for maybe 1 or 3 methods, just do the method injection. Just drop these references and dependencies by the method arguments and do its things inside these methods. This is how the good or maybe good code can looks like. It's not the best one, it's just an example. So as you can see, there is the constructor which gets the hood localization and audio system, and there is the damage method which gets the player who will receive the damage. Pretty easy, pretty straightforward. I hope this is something which looks good for you, because it's important in order to create a great architecture. And I will move forward because I think the time is running out a little bit. And the event dispatcher is my very favorite one. Your game logic can have a huge reference graph. You can have references for every single system in your game, and it can be hard to maintain. It can be hard to read for new developers, and it's kind of quite a complex task to extend these systems. Again, singletons are very often behind this huge reference graph. So you can get rid of them very easily with event dispatcher or some kind of event queue or something like that. It's tricky sometimes, because the naive implementation of this can be significantly costly on the CPU, but it's worth it, because very often this can split your logic easily. You can create events which can be called from different modules, or generally the idea behind the events is you trigger the event and you don't care who listens for this event. You don't care. You just don't want to care who will receive to this event and do its things behind it. So, for example, as you can see, this is very common idea. Again, score manager initialize, spawn player on position, blah blah blah. It's very common in your source code, but we can make it this better using event dispatcher. This previous source code is tricky, because someone needs to maintain this startup method. Someone needs to know, for example, even the order of the methods. Sometimes it's very important to call something before calling the another one. And in many code bases, I just swapped the lines and everything broke up, and that's crazy. It's crazy in these methods. So one beneficial, one advantage of this is that it's really easier to understand the code flow. You just see everything, you can click through it, and very easy. The example with event dispatcher, again, is just an example, but you can have some dispatcher getting through the singleton, but it's just for the demo purposes. But you can inject it, for example, through the constructor or something like that, and you will invoke the event, and you don't care who listens for this event. For example, at the game startup, this can have ton of listeners, but maybe even the one. But you don't care from your game startup class or something like that who will listen for this event. And as you can see, there is some other class who is just registering its listener to this event and waiting when this event is triggered. Pretty easy, pretty straightforward, but it has some disadvantages. The advantages are no hard differences between systems. this can be beneficial because of the performance, limiting breaking API changes, because you're not calling these methods directly, you're just invoking the events. And many often time you don't need to recreate those events or maybe modify them. Or maybe you can create just another one which is more suitable for the use right now. Custom events between Warriors game system, you can just trigger the damage, start the scene or something like that, and everyone can listen and everyone can trigger its own logic. It's hard to understand when those listeners are actually invoked. This is a huge disadvantage if you are starting with new developers or adding new developers to the team. This kind of logic or architecture will be really hard to read. So it's something it's the price you will pay for very flexible architecture or very flexible pattern in your code. The event dispatcher can be pushed further. You can, add some quality of service. For example, more important, more prioritized queues or with lower priority. You can add a parallel processing if you know those listeners will not depends on each other. This can be forced in your team or something like that. You can process the listeners in parallel way, and it's very beneficial for the speed again. And I need to speed up as well. Build time work. Not everything needs to be done actually in the runtime. Many people just create a logic and wait when the game is running and doing its own things. But very often you can hook to Unreal or Unity and do actual changes during the build time. You can save a ton of computing power to doing this. Load scene, modify stuff, strip stuff which are not necessary for your target platform while you are building it, save it, and it's done. Very powerful and can helps you to make your build time the binaries smaller and maybe the faster if you just strip the logic away. Parallel programming, again, architecture. Modern architecture, if you look, for example, into Unreal code base, they are very, very dependent on the parallel processing. And it's absolutely fine because modern hardware and everything from your mobile phone to game consoles are extremely friendly to the parallel processing, and they are nearly requiring from you to make your code in parallel way. This can be significant speed up, but also with great power comes great responsibility. Parallel programming is not fun in some way. It's very hard to do because you can screw it in some place on your code, and it will be hard for you to see it from other side. And it's just very, very hard for you to spot issues while doing the parallel processing or parallel programming in general. But the power which comes with this way of the programming is extremely, extremely big and beneficial for your game or maybe for your project. Just small tips, and at the end, code review. It's something many people talks about it, and it's like a unicorn. Every people talk about code reviews, but nobody been inside of code review or actually doing it. But it's important because you can share the ideas and share the logic for your team very easily, because if you just make a new system, push it to your VCS and wait for the other teams to understand it, it's often a cause of many issues. So just grab your team, sit up with them and discuss the logic and do some kind of code review. Getting different view on your work can be sometimes cruel and maybe heartbreaking, but it's sometimes very, very important to listen and hear those feedbacks. VCS, just think about your VCS structure, branches, feature branches, and try to make those feature branches really, really short-living. Because the architecture is not only the source code, it's also the VCS and the way how you structure and make your work inside the VCS. Just need to speed up. Commit are often not possible. Smaller commits are the better one because it's easy to read and understand for others. There are some guidelines, and also just try to summarize what you have done in one sentence. If you can't do this in one sentence, it's something which can raise alarm in your head, and maybe I did very, very huge part of my work inside one commit. So you can split it or merge it to some feature branch and do the splitting inside it. The last slide, which is also important, comments are not a graveyard for the dead code. This is very often what I've seen. We just get some source code and okay, there is a 1,000 line of code, but nearly 800 is just comments. This is commented out source code, which is not already is used in the code. And why? Why? You have your VCS, you have your history. You don't need to do this. If you are implementing interfaces, empty methods, deserve comments like intentional empty if you are really don't needs to implement them, because sometimes it can be confusing if you have empty interface method. And avoid slow stuff like reflection and exceptions. It depends on your technology or your language and this stuff around, but very often reflection and exceptions are extremely costly. So that's all. There is a Q&A, but I don't think we have a time. We have? Okay. 3 questions are possible. So if you have. Okay.
I'll give you a microphone. Just a second.
Hi, can you recommend some IOC containers for Unity or Unreal Engine, your favorite one?
Oh, the favorite one. This is tricky because I honestly very often fall into the trap creating my own IOC container. But I think in the C#, honestly, I don't remember the correct name. I think it's called Tiny IOC or something like that. Just try to get the lowest or the smallest one IOC container for your game, because for the huge application, for business application, you can have huge IOC containers or dependency injection and this stuff all around, but for the game, you need to be quick and fast. So just decide if it's small and if it's fast. Honestly, we can discuss the specific ones after talk, but right now, you can create your own, or maybe you can just see on the Git or GitHub how big the IOC containers. Just prefer the smaller one because they are often be the faster one.
Okay, thank you.
You're welcome.
There is a question in the back, I think.
Can I ask what is the difference in performance when you use the ECS or job system inside of Unity compared to typical scripting?
Oh yeah, the benefit or the additional speed, it's really dependent how you deeply integrate the logic and how you properly doing this, because it's easy to implement that, but if it's easy also to do it in a bad way, and it can slow up the game in the end. It's absolutely possible if you do it in a bad way. So I can't give you, exact numbers. If you are going to use ECS or job system, your game will behave 50% faster. It's not true. Your game can be 90% faster or something like that. It really depends on your use case and on your situation. But if you follow the guidelines and if you understand really how ECS or job system works, and if you can benefit, make it beneficial in your source code, in the end, it will add you at performance. It depends on your project, on your assets, on your data again. So that's it.